changes on Earth's surface?
Well, because NISAR is a radar mission, it is essentially operating all the time, all weather, day or night. It can even see through clouds, for instance. So what NISAR is actually observing is changes in vegetation and vegetation cover, as well as changes to the ground surface underneath. So those ground surface changes might be reflectivity changes from soil moisture, which is relevant to agriculture, or even surface motion from earthquakes, volcanoes, and subsidence, sort of giving us insight, scientific insight into the processes going on inside the Earth.
And measuring those changes, are there any specific regions here in the U.S. that this data could have a real impact?
Absolutely. So I mentioned earthquakes, which are prevalent on the West Coast. Thinking about volcanoes, they're active in Oregon, Washington State, Alaska. Wildfires are a key issue in the western U.S., and NISAR can observe the vegetation impacts from those. Let's say turning to the southeast, floodwaters from hurricanes, NISAR can track those, and we don't want to leave out the Midwest. A lot of agriculture, NISAR is seeing land subsidence that's due to groundwater pumping and then recharge, which is really important for groundwater management. So pretty much everywhere you go, NISAR will make an impact.
So Adrian, can you tell us why it's so important to make those measurements globally and consistently, like NISAR will be making twice every 12 days?
Yes. In fact, tying back to this earthquake we just heard about yesterday in Kamchatka, that's a perfect example. So thinking about earthquakes and volcanic eruptions, they are massive, high impact, but relatively rare at any given location. So NISAR's got global coverage, continuously operating over all land surfaces. It is actually making these observations, like in Kamchatka, giving us the scientific insights that we can bring back to the U.S., for instance.
Thank you, Adrian. That's great.
Adrian, really appreciate your expertise. Thank you so much for joining us today. So as you heard, NISAR's data can support a lot of communities, especially farmers who can track their crops and how they're changing over time. Here's how.
NISAR is a satellite mission that is going to be observing the Earth with radar. It will actually have 2 radars that view the Earth at different wavelengths. We can combine those data that allow us to learn more about things like vegetation and soil moisture than we can do with only one of those wavelengths.
So NISAR is definitely going to be a breakthrough for field-scale soil moisture, which is one of your main drivers of both food security and then as well more on the economic commodity forecasts.
NISAR is going to look at objects that's the size of about 60 meters in size, which is typical soccer field, to about 200 meters. We'll be able to see whether a particular patch of that size is wet or dry.
The current land surface models can't really quantify irrigation, so NISAR is going to now help understand how much water is actually being used to grow a crop, which will help us save water, so that's kind of a big deal.
Understanding the moisture in the soil can definitely help farmers better understand what's happening underneath the ground. Do they need to water? Is there too much water there? They just need to kind of let things grow. You know, are they in a drought condition? If they do need to irrigate, how much? All those different things just to, you know, better help those farmers make the best possible decisions for their crops.
I truly believe that agriculture is one of the kind of central components to many what we call sustainable development goals. Poverty, nutrition, livelihoods, environment, whether it's water, soil, air, to lift people out of poverty. So it's something I personally believe in philosophically and hope to spread the wealth.
And so how soon can farmers know about their crops?
So the science data from NISAR will start flowing around 90 days after launch. So that will be in the October-November timeframe, just in time for fall harvest, where we'll be getting apple crops and pumpkin crops.
And you were mentioning there is something else that NISAR can measure as well?
Yes, so it can also measure bridges and roads and infrastructure and the land subsidence that can impact those, that type of infrastructure. So very important for how we live on this planet.
And we'll learn a little bit more about that soon enough. So we are just about 59 minutes away from launch and back here at JPL friends and family are starting to gather inside Von Karman Auditorium to watch liftoff. So Sue, who is here to watch launch today?
So we see everybody waving. We have friends and family of the team. Hi, everybody. It's really wonderful to see everybody here. We have engineers, we have technicians, mission operations specialists, and scientists. It's really taken a large community to get NISAR to the launch pad today. I just want to say thank you to everybody who's supported NISAR over the years.
It's great to have them here. So from lush rainforest to dry grasslands, Earth's ecosystems are always changing, but some changes are harder to see from the ground. That's where NISAR comes in, and here to tell us more is Alexandra Christensen. Thank you for joining us, Alexandra.
Thank you for having me.
So how can NISAR help us understand what's happening to forests around the world?
Well, as you know, NISAR has 2 radar instruments on board. The L-band radar is particularly useful for penetrating forest canopies, bouncing off the tree trunks and the ground underneath. This can tell us about the forest structure, the amount of living woody material, and forest disturbance from deforestation and wildfires. We can also track burn severity and ecosystem recovery after a fire. The S-band radar, on the other hand, is more sensitive to the upper layers of the forest canopy, can detect forest thinning or loss of leaves, which could indicate tree stress. And by combining data from both of these bands, scientists can construct a more complete picture of our forest health.
That's so fascinating. So why is it important to see if forests are growing or shrinking?
Yeah, it's super important to see if they're growing or shrinking because forests play a huge role in our planet's health. So, for example, forests are biodiversity hotspots, home to many plant and animal species. So forest loss means habitat destruction and wildlife endangerment. Forests also provide essential ecosystem services, such as regulating our water cycles, preventing soil erosion, and supporting the livelihoods of our communities. NISAR will scan the Earth nearly 2 times every 12 days, and by regularly imaging the same area over time, we can detect small, gradual changes in forests. So NISAR doesn't just measure trees, it also measures trends.
And speaking of ecosystems, can NISAR help us see how ecosystems respond to things like droughts and floods?
Yeah, absolutely. NISAR's radar technology is very effective at observing water, both on the surface and in the soil. And water is a foundation of ecosystems. So during droughts, NISAR is sensitive to water content, so it can see if plants and soils are drying out. Scientists can map moisture stress, which could indicate vegetation decline, increased fire risk, or that groundwater supplies are shrinking. During floods, we can see the extent of flooded areas, even through clouds. Water has a very different radar signature than dry land. So NISAR can see how much land is covered by water and how it's spread. So by comparing...
Thank you so much, and Alexandra, that was really great information. I appreciate that so much.
Thank you.
So NISAR is also sparking curiosity in people of all ages. As part of the NISAR Art Challenge, students were encouraged to imagine Earth the way NASA sees it from space. So Sue, let's take a look at some of those submissions.
Oh, these are really wonderful, Raquel. I love seeing how the kids have imagined how the Earth changes and how we're going to be seeing it with NISAR. We see volcanic eruptions, we see changes in vegetation, we see changes caused by the changing seasons, as well as by natural disasters like volcanic eruptions, by storms, and so many other things. I also love seeing the different ways that the students have used to depict this. We've got crayons, paint, collages. It's really wonderful.
And it's really great artistic work as well.
Yes, and soon we'll have NISAR radar to add to our imagery of Earth's changes.
Fantastic. So to see all the artwork, scan the QR code you see on your screen. So as a reminder, we are about 54 minutes from launch, and soon we'll take you to India for live coverage. So Sue, let's get to some of those social media questions coming in.
Great.
So first off, we have Science of Everything on X, who wants to know, hey NASA, I want to know how you guys got the name NISAR. You explained it earlier, so let's hear it again.
Oh, sure. So the name NISAR stands for NASA-ISRO Synthetic Aperture Radar. And so you can imagine, as a NASA-ISRO partnership, taking synthetic aperture radar measurements, that's how we got the name.
And Manish on YouTube asks, given that NISAR will generate more daily data than any prior Earth-observing satellite from NASA-ISRO, how is NASA preparing to handle process, volume, and distribution of such massive data volumes?
Oh, that's a great question. So NASA, in collaboration with ISRO, but NASA has been working for a long time to prepare for the tsunami of data that we're going to be getting from NISAR. And so one of the key ways that we're going to be doing that is by storing the data and analyzing the data on the cloud.
And we have Suprasha on YouTube wants to know, how will NISAR be helpful for humankind?
How much time do you have? So NISAR will be helpful for humankind by providing data and information that allows us to see what's happening from natural disasters. We've talked about the impacts of natural disasters. It will also help us see the small changes that are difficult to detect with the human eye that can impact the infrastructure on the ground, as well as measuring changes in soil moisture and changes in vegetation that help us understand how we grow food that we need to live. So lots of ways. Those are just a few.
Yeah. I love the list that you created, so thank you so much, Sue. And keep those questions coming using the hashtag AskNISAR. So NISAR will track small shifts in Earth's surface, detecting early signs of volcanic eruptions. Let's take a look.
One of the real key questions in our field of volcanology is to try to understand when is a volcano getting ready to erupt and when is something that we observe happening there just a natural process that isn't going to lead to eruption.
Deformation is often one of the first signs that a volcano is becoming restless, and then we also look for increased seismic activity. But the earlier that we can detect that deformation, the more we can refine what kind of a forecast we have and whether or not we need to be concerned about eruptions.
NISAR has a couple of capabilities that are going to be really transformative for volcanology. The first is the consistency. The fact that we're going to get these incredible data very consistently every couple of weeks. The other aspect of NISAR that's very important is its wavelength. It's got a longer wavelength than most satellite missions that have taken radars up into space. And that longer wavelength means that we're going to be able to penetrate vegetation and be able to see the ground through trees. We're going to get consistency and we're going to get the ability to see through a lot of this obscuring vegetation. And that's really going to open the door for studies of volcanoes.
Because it's expensive and dangerous to put ground sensors around many of the world's volcanoes, many volcanoes around the world have no sensors on them or too few sensors to really understand what's happening.
Having something that's completely remote and satellite-based allows us to get an image of what's going on without needing to have something in the remote ground surface.
The thing about volcanoes is they can have a regional or even a global impact depending on the size of the eruption.
So it's really key to be able to understand how volcanoes work so we can better forecast their activity and warn people that might be impacted by eruptions.
And Sue, there are other natural hazards that NISAR can monitor as well.
Yes, and just recently, in the last few hours, there was a major earthquake in Russia, magnitude 8.8, and NISAR will be very important for being able to forecast as well as assess the damage caused by those types of earthquakes and the tsunamis that they can generate as well.
Oh, thank you for breaking that down for us, Sue. And NISAR's journey to the launch pad was a global effort. JPL built the L-band radar while ISRO built the S-band. The two were integrated at JPL into a single radar payload. That system, along with the boom and reflector, was then shipped 9,000 miles to India. In Bengaluru, teams from both agencies worked together to assemble and test the satellite. After final checks, it was transported to the Satish Dhawan Space Centre in Sriharikota, India, for final launch preparations. This partnership brought teams together from around the world, including JPL systems engineer Akshara Krishnamurthy. She grew up in Bengaluru and has been traveling from California back home to India to support the mission. Let's take a look at part of her journey.
Hey everyone, I am at LAX right now. I just finished security and I'm ready to board. It's the first of 3 flights with a stopover in Dallas, Soha, and Bangalore. I have arrived in Bangalore Airport, or as we call it, Bengaluru, after about 31 hours of flying. I'm excited, but I'm also super tired, so I'm going to go get my bags and head to the hotel, and I'll see you later. This is where I grew up in Bangalore. It is amazing and nostalgic, in fact, to come here because it was my dream job to work at NASA. And now I'm able to contribute to my home country on a project where we're doing an international collaboration. So super excited to be a part of this effort and also grateful for this experience. So finally, I'm here at the URL Satellite Center, URSC, here in Bangalore. This is the ISRO center where we're going to be working the next few days. We're gearing up for our next set of system level testing. Today we're going to have a day full of intense technical discussions with the NISAR team here at ISRO right behind me. I'm walking in to Rajasthani. It's a traditional Rajasthani cuisine restaurant. You will get to see one of India's cuisines. It has 28 states, and each state has its own cuisine. And here we explore different types of cuisines with our ISRO colleagues and friends. We're waiting for the traditional lamp lighting ceremony, what we call the diyas. And the background music that plays is really world peace and happiness prayer. It was so soothing and it was such a positive energy here. I wish you could all witness this. Thank you for joining me on this tour of my city. I hope you enjoyed it as much as I did. I can't wait to see the launch and operate this amazing observatory.
So you also traveled to India for this mission.
Yes, I did. It was really an amazing experience. It was my first trip to India. I went in February of 2020 to meet with the science team in India, and again a few years later.
You know, speaking of travel, NASA leadership is on the ground right now in India getting ready for launch. Here's what they had to say.
I'm here in India, super excited as we are here to support our NISAR mission as it takes to the skies. And today, it's all about NISAR.
It's an exciting week for NASA. We have our Crew 11 launch in Florida, and we have our NISAR launch here in India, which is where I am with our NASA teams. Super excited to be here, an incredible collaboration between India, the United States. This launch really represents the culmination of over 10 years of collaborations between our two countries. So go NASA, go JPL, go ISRO, go NISAR.
I'm here today at IIT Madras for the pre-launch science team meeting for the NISAR mission. We are learning all about the terrific science that's going to come out of this mission. I just heard about how NISAR will revolutionize our understanding of how earthquakes happen around the globe. The excitement for launch here is palpable, and I can't wait to get back inside and hear more.
Go NISAR indeed. And to help us better understand the spacecraft, you have brought a model with us.
Yes, so here we have a model of the NISAR spacecraft. You can see here we have solar panels to power the spacecraft. Here we have in this octagonal structure, this is the radar instrument structure, or the RIS. So the L and the S-band radar are housed here. And then behind that is the spacecraft bus, which houses the power and the telemetry and other key functions of the satellite. Then attached to that is this impressive boom that holds up the nearly 40-foot in diameter gold reflector antenna reflector of NISAR.
And so it is not going to launch in this configuration, right? It has to be packed up. So how does that work?
So right now it's all folded up and stored and ready for launch. And so the way that it folds up is this boom actually wraps around the radar instrument structure. But first, the antenna reflector folds up. So it kind of collapses like an umbrella or a camp chair, and then it's stored underneath the radar instrument structure in this configuration, and it's held in place by this little latch down here.
Well, that is exciting stuff. Thank you so much for the breakdown, Sue. So NISAR is a joint mission between NASA and ISRO, but that is just one example of how our two countries are working together in space. So here's more in your Artemis Moon Minute.
NASA's Artemis campaign uses missions on and around the moon to prepare for future human missions to Mars and highlights a new era of international cooperation championed through the Artemis Accords. Established in 2020 by the United States, led by NASA with the U.S. State Department and 7 other initial signatory countries, the Artemis Accords outline a practical set of principles, such as peaceful purposes and transparency, to guide space exploration cooperation. India became the 27th country to sign the Artemis Accords in Washington, D.C. in June 2023. Later that year, NASA and the Indian Space Research Organization, or ISRO, cooperated on a first-of-its-kind lunar experiment. They transmitted a laser beam from an orbiting NASA spacecraft to a small reflector device on ISRO's Vikram lander on the moon. This method of precisely locating targets on the moon could help guide Artemis astronauts to the surface in the dark or mark the locations of spacecraft already on the lunar surface, so astronauts or uncrewed spacecraft can land near them. As of today, over 50 nations have signed onto the Artemis Accords. And that's a look at your Artemis Moon Minute. The Artemis mission, scan your QR code you see on your screen. And as you do that, it's also worth mentioning another NASA and ISRO partnership. Last month, ISRO made history with its first astronaut visiting the International Space Station as part of the NASA and Axiom Space's AX-4 mission. Shifting gears back to NISAR, the Earth-observing satellite is set to give scientists a clearer view of how ice is moving, melting, and reshaping our world. Here to tell us more is Eric Vigneault. Thanks for being here today.
You're welcome.
So how can NISAR help us understand how tracking melting ice from glaciers and ice sheets is important?
NISAR will track the motion of glaciers and ice sheets and combine with information from climate models and thickness of the ice, we can figure out how much they contribute to sea level rise. And glacier melt is one of the main contributions to sea level rise. We need this information to inform society on how to protect ourselves from sea level rise. And then the scientists will be able to use this information in climate models to project what sea level would look like in the next few years, in the next decades, in the next century, so we can better protect society and save human lives too.
Very important information.
So Eric, can you tell us how will NISAR help us see changes in the ice that are difficult to detect from the ground?
Yeah, so NISAR will cover the globe in 12 days, and in particular it will cover all of Antarctica for the first time. And conducting these measurements in the Antarctic would be nearly impossible for ground parties because the continent is so vast. It's larger than the United States. And it would put these field teams in great danger if they had to do this work continuously on the Antarctic. So with NISAR, we'll have this information continuously about what's happening in the Antarctic. If there's any important event, we'll see it, we'll catch it, and it will be part of public knowledge from this data.
Thank you, Eric.
That's great. Eric, that was really important information. Thank you so much for joining us today. And let's take another look into mission control here at JPL, where the team is excited to watch launch. And just a few days ago, I had a chance to speak with Dave Gallagher, the new director of JPL, to hear his thoughts on launch. Dave, thank you so much for joining us today.
It's my pleasure, Raquel. I'm happy to be here.
From your perspective, why is NISAR such a groundbreaking collaboration between NASA and ISRO?
This is the single biggest collaboration in space between the United States and India. It's enormously important to both countries, and space diplomacy is key right now. One of the most challenging things about this collaboration is the difficult time zone. So we have our JPL engineers and scientists working shoulder to shoulder with their ISRO counterparts, and the team is just working fantastic together.
When people think of JPL, they probably think of Mars rovers or deep space exploration, but JPL is also dedicated to studying Earth science and our home planet. What do you hope NISAR will achieve that adds on to those many Earth missions?
Well, Raquel, just to build on what you said, we actually have 4 decades of pioneering missions to really understand our home planet, missions like GRACE, missions like EMIT, like SWAT, that are born here and really have turned out to be some of the most important missions in existence to understand our home planet. NISAR is going to give us an unprecedented view of the Earth, both our ice mass, land mass, and because it's synthetic aperture radar, which is a technology really pioneered at JPL, it can work day and night and through any kind of weather.
Can you tell us how the JPL team contributed to NISAR and what that says about JPL's history of working on international partnerships?
Absolutely. This will be the first mission to use 2 kinds of radar. The L-band radar is developed by JPL. The S-band radar is developed by ISRO. And that combination of those 2 radar systems will allow us an unprecedented understanding and view of the Earth. NISAR builds on JPL's long-standing legacy of working with international partners. We can drive innovation when we take advantage of each country's strengths. We are actually stronger when we work together than doing this alone.
So looking ahead, what kind of legacy do you hope NISAR leaves behind for future Earth science missions?
What I'm most excited about with NISAR is the real-world applications, things like infrastructure monitoring, natural disaster recovery and response, agriculture management. This is going to make a real difference for real people around the world.
Thank you so much for your time and insights today.
Thanks.
As a reminder, this is a joint broadcast, and we will hand it over to ISRO, who will cover NISAR's launch, which is just about 36 minutes away. And Sue, we have another social media question coming in. So Pradeep on X wants to know, how will NISAR's satellite be different from others, and what capabilities does it have which others don't?
That's a great question. So a key difference from NISAR is that it is going to be globally measuring at very high spatial resolution. So this is the technology or the capability enabled by the radar technology that is called SweepSAR, as well as the very large antenna reflector that we saw earlier. Another key innovation from NISAR is the dual band radar. It will be the first satellite to be measuring with both L and S band.
Well, thank you so much for those questions. And if you have a question, send them over using the hashtag AskNISAR. And as we showed you about 15 minutes ago, NASA leadership is on the ground right now in India. That includes Associate Administrator for Science, Nikki Fox. I was able to catch up with her before she left to talk about this historic partnership. Nikki, thank you so much for joining us today.
Oh, you're so welcome. It's a great day.
NASA has more than 24 missions focused on Earth science right now. What makes NISAR unique?
We really don't quite understand why our planet is always moving. The surface of the planet is always kind of moving, and we can't detect it. But with this amazing technology that NISAR brings, they were going to be able to actually start studying these tiny little, almost landslides, these little tiny quakes. And the goal, of course, being that we find a signature that happens before a major disaster that would allow us to then look for that and search for it and almost be able to predict these big disasters before they happen.
And you mentioned those tiny changes that this mission will track. what kind of other insights may we gain that could help people in their everyday lives?
We're also getting the data into the hands of people that need it, the decision makers, the people who are working with the first responders to actually go in and help people once these disasters have happened. You mentioned how many missions we have in the Earth Science Fleet. And you know, when you put all these missions together, you just get so much more out of them. And so having NISAR launch take its place in the Earth Science Fleet, really illuminating so much more about our home planet, NISAR is just going to give us unprecedented views to add to the information we have about our planet.
And Nikki, we are so close to launch. So what are you looking most forward to right now?
Oh my goodness. I love a good launch. I'm not going to lie. I'm a launch junkie. I love everything about them. But really it's that final sort of when you get to that final countdown and, you know, you just appreciate, for me, being with the team, being with this combined team who've worked so hard to make this happen. I know I've been on mission teams and you kind of it's almost like you're sprinting to the start line as a scientist. You've done all the work, the mission is there, it's on the rocket. Once it launches, all of the science begins.
Fantastic. Thank you so much for joining us today.
Thank you so much. Go NISAR.
And Sue, we have more social questions coming in, so why don't you answer some more? We have Ayush on YouTube who wants to know, how long will it take to get NISAR fully running?
So that's a good question. So it will take about 90 days before we start collecting, before the science mission starts and we start collecting science data. So in those 90 days, we will be deploying the satellite, deploying the boom and the reflector, as well as testing out all of the radar instruments and making sure that everything is calibrated and validated initially correctly.
So 90 days from now will be like Christmas for you.
Yes, it will.
And Rian on YouTube wants to know, how will ISRO and NASA ensure NISAR's data is accessible and useful for developing nations most affected by climate change?
Oh, that is a wonderful question. So NASA has an open science policy and open data policy. And so all of the data that NISAR will be collecting, all of that L-band data will be available through a NASA archive at the Alaska Satellite Facility, and then India will also be making their data available, the S-band data and L-band data that they will be processing available and openly free and available to everyone through their data archive as well. So all of the data will be free.
Great, and we have a couple more coming in. Raul on X wants to know, why is NISAR's antenna so big compared to other Earth-observing satellites, and what is it made out of?
So I can answer the first question. I don't think I have the exact facts for the second question about what it's made of. But the reason why it needs to be so large is that area gives us the very high spatial resolution that is going to be unique to NISAR, combining that global coverage as well as the high spatial resolution. So we need that surface area to collect all the reflected radar signal from the Earth, focus it onto the receiving antenna, and that will give us the high spatial resolution.
Thank you, Sue. So Angene018 on YouTube wants to know, since NISAR uses both L-band and S-band SAR, how does the dual-band radar improve surface imagery accuracy, especially in densely vegetated and urban regions? These are some great questions.
Yeah, so how will the L and S-band radar help us improve the surface deformation?
Vegetated and urban regions.
Vegetated and urban regions. So that because the two different radars are different wavelengths, they will be sensitive to different parts of the vegetated environment, and so we'll be able to characterize the vegetated areas more accurately using the two different wavelengths.
Really appreciate your expertise, Sue. Thank you so much, and thank you all for your questions. So Sue, launch is just 30 minutes away, so tell us how much this moment means to you and the NISAR team?
You know, this is so special. I've been working on NISAR, been part of the team for over 10 years. I know people have been working on this mission concept for decades. And so it's really an amazing moment to finally be here at launch. And we're just so excited to be starting the science observations, to start collecting the data. It will be so impactful for so many people on the planet.
Great, Sue. So we will now take you to the Satish Dhawan Space Centre in India for coverage of liftoff in about 30 minutes from now. Remember, NISAR is a joint mission between NASA and the Indian Space Research Organization, or ISRO. Part of ISRO's coverage will be in Hindi, but we will be having an interpreter providing English translations so you can follow along. And we will see you again after liftoff.
Mission intends to place the NISAR satellite weighing about 2,400 kilograms in 747.4 kilometers circular polar sun-synchronous orbit with an inclination of 98.4 degrees.
Namaskar, Shubh Sandhya.
Good morning, good evening. There is a historical day in this
NASA और
experienced agencies NASA and ISRO.
उपग्रह जिसे हम निसार NASA ISRO
We say NASA-ISRO synthetic aperture radar. We know
के साथ एक स्वर्णिम अध्याय लिखा जाएगा जो कि अंतर्राष्ट्रीय सहयोग
we will be writing a new history in the international space.
घटना के मैं विकास स्वर्णकार आप सभी का
So my name is Vikas Swarnakar. I welcome everybody in this lunch. I will be Madhuri will be here. She will be commenting in English. So we are at the Sriharikota Satish Dhawan Space Centre.
GSLV S16 NISAR mission के
GSLV S16 NISAR 30 July 2025 Indian time 5:40 p.m. 25
GSLV S16 का
GSLV S16
किया जाएगा। इस प्रमोशन मिशन का उद्देश्य है
2400
किलोग्राम वाले भूप्रेक्षण उपग्रह नाइसार को 747 किलोमीटर की गोलाकार
747 kilometer
इस प्रमोशन मिशन को पूरा करने के लिए
this mission to complete GSLV the space vehicle is used.
इससे पहले यह 17 उड़ानें
Before this it has done 17 launches.
साल ही हमने 29 जनवरी 2025
this year 29 January 2025 GSLV F-15 NVS-2
सफलतापूर्वक प्रक्षेपण देखा।
So we have successful launch has been done already.
मिशन जिसका नाम है
So next mission will be GSLV S16 NISAR mission.
NISAR is the world's most sophisticated Earth observation satellite, jointly developed by ISRO and NASA. Its 12-meter deployable mesh antenna is one of the largest in Earth observation history and uses a unique operating mode called sweep-SAR to observe Earth with a swath of 242 kilometers and a high spatial resolution. NISAR will carry L-band and S-band radars which are designed to work independently or together. While the L-band radar contributed by NASA will work with longer wavelengths of about 25 centimeters to penetrate vegetation, soil, ice, detailed tracking of soil moisture, forest biomass, ice sheet thickness, and subsurface features. The S-band radar contributed by ISRO will operate on shorter wavelength of 12 centimeters, which makes it highly sensitive to surface characteristics. It is useful for detecting crop structures, snow cover, and fine surface deformation.
NISAR, NASA-ISRO synthetic aperture radar,
NASA
द्वारा संयुक्त रूप से विकसित
this is combined mission.
वेधशाला है। इसकी खास बात यह है कि नाइसार
specialty of this
मानचित्र तैयार कर पाएगा और पृथ्वी के पारिस्थितिक तंत्र, बर्फ का द्रव्यमान, वनस्पति बायोमास, समुद्र के स्तर की में वृद्धि,
independently
भूकंप, सुनामी,
benefit vegetation, soil,
प्राकृतिक खतरों
landslide.
डेटा प्रदान करेगा.
It will provide the good data.
अब आप सभी दर्शकों के सामने GSLV
F-16 launch vehicle integration video will be presented.
Video of GSLV F-16 mission here at Satish Dhawan Space Centre, Sriharikota. The launch campaign begins with the flag off of the nozzle end segment from its preparation building to the vehicle assembly building, where it is being handled and carefully positioned on the mobile launch pedestal. The first stage of GSLV consists of 5 solid motor segments, which have a case-bonded HTPB-based solid propellant. It has a nozzle end segment, 3 middle segments, and 1 head end segment. On your screens now is the handling of head end segment. That is the igniter being integrated on the top of the first stage motor, the interstage 1-2. It is a vented interstage to enable hot separation of GS1. The strap-on motor is called the L40s, being prepared in a separate building, handled and moved to the vehicle assembly building to be tilted and then assembled with the core motor. L40 strap-ons in GSLV. You can see on your screens it has completely been assembled.
अभी आपने प्रथम चरण का
संयोजन देखा, first stage combination
प्रयोग करते हैं और अभी आप देख रहे हैं यह द्वितीय चरण है.
You're seeing second phase GSLV Mark II.
GS2 HT कहते हैं.
We say GS2 ST.
चरण है और इसमें आप देख सकते हैं
this is the liquid propeller.
इसमें भारत पूरी तरह स्वायत्त प्राप्त कर चुका है. इसके पूर्ण परीक्षण के पश्चात
after the full experiment,
अंतरिक्ष केंद्र लाया जाता है. आगे के परीक्षण के पश्चात इसे यान में.
So after the further experiment,
क्रायो स्टेज है, तृतीय चरण है.
This is the cryo stage, third stage GSLV
है जो
this is the last stage
का प्रयोग करता है,
which is a cryo fuel
ऑक्सीजन तथा
is used. Liquid oxygen and liquid hydrogen will be combinedly used. This is the last stage.
इसके ऊपर में
so on top of this
उपग्रह को समायोजित किया जाएगा और यह है.
So it will be combined here.
On your screens now is the spacecraft NISAR. In the visuals before this, you have watched the integration of the second stage of being operated on Earth storable propellant and then the cryo stage, and these are the visuals. Craft preparation facility, the clean room where the encapsulation of the spacecraft is taking place.
पूर्ण परीक्षण के पश्चात
after the full experiment, this satellite will be encapsulated.
Vehicle assembly building लाया जा रहा है.
So VAB vehicle assembly building has been brought after careful security and quality. It will be combined with the space vehicle.
और इस तरह पूरी तरह तैयार.
In this way, fully prepared
GSLV
for this completion of the mission.
VAB से UT की तरफ लाया जा रहा है, umbilical tower की तरफ.
Towards the tower.
That's it has the movement of the fully integrated GSLV F-16 to the umbilical tower of the second launch pad.
आगे की गतिविधियां तथा परीक्षण.
So further activities and the experiment will be done with the tower.
जांच यहां से पूरी की जाएंगी.
So all the health checkup will be completed here.
We are about 20 minutes away from the launch. The countdown for this mission was 27.5 hours long, and it had started yesterday, that is the 29th, at 14:10 hours here.
GSLV F-16
GSLV
की उल्टी
F-16
गिनती 27.5 घंटे पूर्व
the countdown will be 27.5 have been started.
अभी अभी आप सभी दर्शकों ने सुना रेंज ऑपरेशन
You
डायरेक्टर
have
ने
seen,
अपने तंत्र की
you have
सूचना मिशन डायरेक्टर को दे दी है.
mission director has given the information.
उड़ान की उल्टी गिनती जारी है और उसी के अनुसार
countdown is continued
से जारी हैं.
of this space vehicle.
पश्चात स्वचालित प्रक्षेपण अनुक्रम यानी ऑटोमेटिक लॉन्च सीक्वेंस शुरू किया जाएगा.
Automatic launch sequence is going to be started.
इस दौरान यान निदेशक
In this way,
डायरेक्टर
the director,
टेलीमेट्री ट्रैकिंग कमांड
मिशन डायरेक्टर रॉजर
और सैटेलाइट डायरेक्टर अपने
satellite
तंत्रों की
director
सूचना मिशन
are also giving the information to the mission director.
During the countdown, the servicing operations for the Earth storable propellants into the GS2 stage and the 4 numbers of L40 strap-ons was carried out. Health checks were carried out on the spacecraft and the launch vehicle. The meteorology instruments will indicate crucial data to comply to the launch commit criteria. Radars carry out transmission checks and cryopropellants are serviced few hours ahead of launch.
Mission Readiness Review Committee and the Launch Authorization Board have granted clearance to proceed with the countdown and launch of GSLV F-16 NISAR mission. All operations up to the initiation of automatic launch sequence have been completed satisfactorily. Based on the clearances received for the launch vehicle, spacecraft, range systems, ISRO ground stations, and considering the favorable weather conditions, Mission Director hereby authorized the commencement of launch operation sequence for the GSLV F-16 NISAR mission at 17 hours, 40 minutes and 25 seconds IST today, the 30th July 2025.
This is Vehicle Director. Pre-launch operations of cryo stage is authorized.
To note, Mission Director has given authorization for the launch of GSLV F-16 NISAR mission.
अभी आप सभी दर्शकों ने सुना सभी
all the viewers have heard
रूप से कार्य करते हुए और उनके तंत्रों की जानकारी मिशन निदेशक तक पहुंच चुकी है.
working.
तत्पश्चात मिशन निदेशक
The information has already been disseminated.
अनुमोदन प्रदान कर दिया है.
So the approval has been given.
Automatic launch sequence has been authorized by the mission director. In the preceding 14 minutes before launch, a capsule of crucial functional aspects of launch vehicle systems, which includes actuation of liquid stage engine actuators, health confirmation of ground systems that are crucial for the launch, and very close to T0, control is passed on to the onboard computers.
अब हम उड़ान से 17 मिनट की दूरी पर हैं.
We are 17 minutes away from the launch.
होने के पश्चात यान को पावर
So after the countdown has been begun,
द्वितीय चरण जो है तरल
GS2 second stage.
उसके बाद L40 चरणों में
after this
जो
L40
चरण है उसमें भी तरल नोदक का भराव सुनिश्चित किया गया. मिशन कंप्यूटर और रडार उपकरणों की स्वास्थ्य जांच की गई. क्रायो आर्म
the health has been checked up.
फिलिंग के लिए तैयार
ईंधन का filling has been prepared and it has been assured.
सभी स्वास्थ्य जांच पूरी की जा चुकी है. एयर ट्रैफिक कंट्रोलर तथा जल
ट्रैफिक कंट्रोलर्स
अनुमति प्राप्त की जा चुकी है. हमारे मौसम विभाग से भी पूर्व सूचना प्राप्त की गई है और इस दौरान मौसम पूरी तरह
weather is
अनुकूल बताया गया है.
Ideal for the launch.
Automatic launch sequence जारी है.
Automatic launch sequence is continuous.
-16 minutes.
Automatic launch sequence.
Authorization.
Computer
automatic launch authorizes
जांच पूरी की जाएगी.
Initiate automatic launch sequence for the launch of GSLV F-16 NISAR mission.
GS servers activated. MC confirms data from SHAR-1 and SHAR-2.
GSLV F-16 mission at the second launch pad. It's getting ready for its first ever mission to sun-synchronous polar orbit.
Automatic launch sequence initiated for GSLV F-16 and NISAR mission.
ALS in auto mode.
Tank PLO operations commenced.
NISAR उपग्रह L और S बैंड
NISAR satellite
Aperture रडार वाला उपग्रह है जो उच्च विभेदन के साथ बड़े प्रमाण को प्राप्त करने के लिए CSAR तकनीक से संचालित होगा। नासा के जेट प्रणोदन प्रयोगशाला
NASA's Jet Propulsion Laboratory
सहयोग से तैयार
with ISRO. This has been prepared.
राष्ट्रीय जरूरतों को पूरा करेगा।
This not only addresses the national necessity, this will be providing the data to the whole world. It's a combination of two cultures and then the best creation.
.7-meter tall GSLV is a 3-stage launch vehicle of 420.5 tons liftoff mass. The first stage, GS1, comprises of S-139 solid booster and 4 strap-ons of liquid L-40. The second stage, GS2, is Earth-storable liquid stage of GL-40 HT.
L-40 EGC actuation in progress.
The third stage, GS3, otherwise called CUS-15, and is powered by cryogenic propellant combination of LOX and liquid hydrogen. The payload fairing is of ogive shape with 4-meter diameter.
यह रचना आपके सामने प्रस्तुत है GSLV F-16 प्रमोचकयान की
GSLV F-16
7 मीटर इसका कुल उत्थापन भार
51.7 meter the height, so its mass is 420.5 tons.
स्ट्रैप-ऑन्स लगे हुए हैं। द्वितीय चरण में L-40
the second stage
ऊपर स्टेज
L-40 and then
वाला चरण है
so this is the
और ऊपर
cryo engine stage, third stage.
पूरी तरह सुरक्षित है।
So our NISAR is fully protected.
Payload pairing 4 मीटर
payload pairing
वाली ओजिव payload pairing
4 meter.
किया जा रहा है।
L-40 EGC actuation completed.
सभी गणमान्य व्यक्ति यहाँ उपस्थित लॉन्च का अनुभव लेने यहाँ
everybody are attending, the distinguished guests.
GSLV F-16 की उड़ान दक्षिणी
GSLV F-16 flight would be from the south direction to keep it in the tracking range. Radar tracking station
मॉरिशस और अंटार्कटिका में स्थित हैं।
Antarctica,
निगरानी रखेंगे
Mauritius.
और हम तक सभी आंकड़े वास्तविक समय पर उपलब्ध
So we will be getting all the data on the real time.
We are 11 minutes 45 seconds from the launch. In the preceding several months, both ISRO and NASA have disseminated information and data characteristics to enable prospective users to take full advantage of the data gathered by NISAR when it becomes available.
सभी वैज्ञानिक अपने कंसोल पर
all the scientists are studying their data.
अभी तक
all the technologies are working fine.
लॉन्च व्यू गैलरी का दृश्य
You're seeing the gallery of the launch, the encouragement, all the students here, big numbers, they've been presented here, they're gathered here to experience the launch of this satellite.
Exuberant spirits of the students here at the Launch View Gallery at Sriharikota.
उत्साह देखते ही बनता है छात्रों का
So the inspired students encouraged here.
पल मिला है जब
This is the moment they've been getting.
यह प्रमोशन देख सकते हैं.
Again, you can see this launch.
T-minus 10 minutes.
GS2 radar engine actuation in progress.
ISRO is bringing to you a curtain raiser for the mission NISAR for your better understanding about the mission.
In an era where climate change dominates global discourse, humanity faces an increasing vulnerability to natural disasters. To address these mounting challenges, NASA and ISRO have joined forces in an extraordinary collaboration to launch the NASA-ISRO Synthetic Aperture Radar Satellite, NISAR. This groundbreaking low Earth orbit LEO observatory promises to revolutionize the way we understand our dynamic planet. Equipped with state-of-the-art LNS-band synthetic aperture radar, SAR systems, NISAR will use the sweep SAR technique to deliver high-resolution images across vast swaths of the Earth's surface. Incredibly, it will map the entire globe every 12 days, offering unprecedented consistency in spatial and temporal data. NISAR's mission is nothing short of transformative, from tracking glacial melt and monitoring agricultural landscapes to analyzing seismic shifts and managing disaster response. It will empower scientists, researchers, and policymakers with vital insights. By precisely measuring minuscule movements and colossal environmental events alike, NISAR will help us decode Earth's complex ecosystems and natural hazards. The flagship mission sees NASA contributing the L-band SAR, engineering payloads, critical systems like GPS receivers, and the solid-state recorder. ISRO supplying the S-band SAR, spacecraft bus, and will launch the satellite aboard through its vehicle GSLV F-16 from Sriharikota. A majestic 12-meter unfurlable reflector antenna will unite the dual-band systems, enabling powerful Earth observations from orbit. The geosynchronous satellite launch vehicle, GSLV F-16, features a three-stage configuration. Its first stage comprises a solid rocket motor at the core, support 4 liquid strap-on boosters. The second stage operates on liquid propellant, while the third and final stage is powered by an indigenously developed cryogenic upper stage. The payload fairing for the GSLV F-16 NISAR mission features a 4-meter diameter OGIV configuration. The launch will take place from the second launch pad at India's spaceport, SDSC Shar at Sriharikota. It is the first GSLV mission to be launched into a sun-synchronous polar orbit. NISAR is not just a satellite, it's a symbol of global unity, scientific excellence, and hope. It promises to safeguard our future by helping humanity live more wisely with nature.
T-minus 6 minutes.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है और अब हम 6
Automatic launch sequence is continuous. We are 6 minutes away from the launch.
प्रमोशन का विवरण देते हैं।
So we will give you the details of this launching.
से बना हुआ ज्ञान है। प्रथम चरण में
So 3 stages with S139
है जो कि PSLV से व्युत्पन्न
which is PSLV-7.
प्रथम चरण के साथ 4
The first stage, so the liquid propeller will be used L40
द्वारा संचालित किए जाते हैं। 4 S139
gas engine
मोटर के साथ मिलकर कुल 8000 किलो न्यूटन का प्रणोद उत्पन्न करते हैं।
8000 किलो न्यूटन
आवश्यक होता है यान के उत्थापन के
This is required for the lift of the spacecraft.
किलोमीटर की ऊंचाई प्रदान करेगा तथा इस समय
54 kilometer height.
L40 strap-on
L40 is strap-on.
प्रज्वलित रहता है
150 seconds.
600 मिलीसेकंड बाद द्वितीय चरण प्रज्वलित होता है और इसके तुरंत बाद प्रथम चरण के यान से पृथक कर दिया जाता है।
So it will be separated from the first.
नोदक वाला चरण है।
So again, second stage is the liquid
द्वितीय चरण
space.
विकास इंजन के साथ 846 किलो न्यूटन का प्रणोद उत्पन्न करता है।
846 किलो न्यूटन
प्रज्वलित
146 seconds. It will be ignited. 3.5 kilometer per second relative velocity. During the second stage,
क्लोज लूप गाइडेंस के अंतर्गत अपना दिशा निर्देश द्वितीय चरण की समाप्ति के पूर्व ही तृतीय चरण
after the completion of second stage, the third stage will be started. The cryogenic fuel
और सबसे जटिल
GSLV, the third and the last stage. In this cryo stage, the ignition
अतिरिक्त प्रणोद के लिए कमांड दिया जाएगा।
So the command will be given for 11%
क्रायोजेनिक इंजन का
additional
75 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह
के
साथ यान लगभग 400 सेकंड में 780 किलोमीटर की ऊंचाई प्राप्त कर चुका होगा और सापेक्ष गति 4.57 किलोमीटर प्रति सेकंड। इसके पश्चात क्रायो चरण को पुनः सामान्य प्रणोद के लिए कार्यशील किया जाएगा और फिर 400 सेकंड
after that 400 second 7.5 kilometer per second relative velocity will be applied.
की स्थितियां प्राप्त करेगा।
So it will be getting
1115 सेकंड पर पूरा किया जाएगा।
All these activities will be completed.
The launch. Let us take a quick look at the mission events for GSLV F-16 NISAR mission. The L-40 strap-ons ignite 4.8 seconds ahead of T0 so that their nominal thrust can before igniting the booster. Liftoff coincides with the ignition of S-139, also called as GS-1 at T0. The burn time of GS-1 is 112 seconds and that of the L-40s is 149 seconds. By the time GS-1 and L-40s finish their operation, the launch vehicle is at 104 kilometers altitude. In a staging event typically called as hot separation, the GS-2 stage is ignited 600 milliseconds after the L-40 thrust cutoff and 1.6 seconds later, the stage separation takes place. When the launch vehicle reaches 138 kilometers altitude, the dense atmosphere would have cleared. Since the need for thermal shielding and aerodynamic shape is no longer significant, the payload fairing is jettisoned. Closed loop guidance also is initiated. At this point of time in the mission, the launch vehicle would have acquired 2.1 kilometers per second relative velocity. For the present mission, the burn time for GS2 is 140 seconds. It is separated 4 minutes 53 seconds into the flight. The third stage is the cryogenic upper stage, which plays a significant role in the mission. Its high specific impulse together with a long burn time of more than 13 minutes, it adds tremendous relative velocity to the CUS operation adds 376.55 kilometers
stand by for the time mark.
and increases relative velocity from 3.5 kilometers per second to 7.5 kilometers per second. An operational philosophy unique to the GSLV F-16 NISAR mission is that CUS stage is operated by 11% for the duration of 405 seconds. About 11 minutes into flight, the cryogenic upper stage shuts down. The satellite NISAR is separated to be injected into an altitude of 745.5 kilometers with a relative velocity of 7.57 kilometers per second.
Minus 25 seconds.
We are mere 25 seconds from the launch.
Minus 20 seconds.
सभी दर्शक हमारे साथ बने रहिए.
So please stay tuned with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust. S139 motor ignited.
5 seconds.
That's a magnificent tracking of the GSLV F-16 NISAR mission. The deafening roar of GSLV and beautiful silhouette brightening the Sriharikota sky.
जी हाँ, अभी आपने देखा चारों
You see L40
सफल प्रज्वलन और GSLV
successful launching.
की ओर बढ़ता हुआ.
This is going to the destination.
हम यहाँ कंपन महसूस कर पा रहे हैं.
We are experiencing the vibration here in this mission station.
S139 solid core motor and 4 L40 liquid strap-ons thrusting together. 7,800 kilonewton cumulative thrust.
First stage performance normal.
Sharon is in Venato.
The day of launch wind biasing program that is fed into the onboard computers helped the rocket to veer through the atmosphere with minimal aerodynamic loads.
प्रथम चरण का कोर बूस्टर लगभग
The first stage core booster will be ignited.
L40 चरण
L40 stage 150 seconds it will be calm. So after that it will be separated from the craft.
अपने अपेक्षित पथ का अनुकरण करता हुआ
First stage performance normal.
Currently the rocket is in open loop guidance. SHAR ground station is tracking.
S139 burnout.
कोर बूस्टर का प्रज्वलन समाप्त हो चुका है.
So it has been completed. The ignition of core booster
has stopped its operation. The 4 L40s are thrusting still.
First stage performance normal.
प्रथम चरण का कार्य निष्पादन पूरी तरह सामान्य.
The first stage is normal. This is going to its launched direction. L40 is ignited, so it will be 50 seconds duration.
GS2 ignited, GS1 separated. 1S, IS 1/2 main separated.
जी हाँ, अभी आपने सुना रेंज ऑपरेशन.
Yes, you saw.
पुष्टि की है.
Range operation director has
पृथक किया जा चुका है.
confirmed.
चरण का प्रज्वलन शुरू हो चुका है.
The second stage ignition has been started.
The flight, the GS1 has undergone a hot separation and GS2 commenced its operation and thrusting nominally. The payload fairing has also been separated and closed loop guidance has been initiated.
जी हाँ, इस दौरान
वातावरण
से बाहर, इसलिए पेलोड फेयरिंग या ऊष्मा कवच की आवश्यकता
थी,
इसलिए इसे यान से पृथक कर दिया जाता है.
So this has been separated from the
गाइडेंस के अंतर्गत है और स्वतः ही
spacecraft,
निर्धारण कर रहा है.
and then this is going to its own direction.
That uses the Earth storable propellant combination of UH-25 and N2O4. The second stage of GSLV develops 846 kilonewton thrust in vacuum. Burn time for this mission of GS2 is 140 seconds.
Plus 4 minutes.
दर्शकों का उत्साह देखते ही बनता है यहाँ पर।
So we are seeing the encouraging viewers here.
द्वितीय चरण सामान्य निष्पादन करता हुआ
So second stage is in its normal ignition.
इसमें इस चरण में US-25 तथा N2O4 ईंधन का प्रयोग किया जाता है।
In this stage, US-24 and N2 is used.
लगभग 150 सेकंड का होगा।
So around 150 seconds time for this ignition, like we previously mentioned, second stage.
चरण को अनुमोदित कर दिया जाएगा।
So after finishing the second stage, the third stage would be started.
GS2 thrust cutoff.
The
GS2 separate.
completed its operation and jettisoned from the ongoing vehicle.
द्वितीय चरण के सफलतापूर्वक प्रदर्शन के पश्चात
second stage completion, successful completion has been achieved. This is the third stage, the last stage has been, this is the complex stage. So we can see the viewers encouraging viewers.
Its operation.
The cryo stage operating at operated level.
The CUS stage with CE 7.5 engine with liquid hydrogen as fuel and liquid oxygen as oxidizer with a nominal thrust of 73.55 kilonewton. In this mission, there will be a thrust upratement of 11%, that is
cryo stage performance normal.
4 kilonewtons for about 405 seconds.
Plus 6 minutes.
वर्तमान में तृतीय चरण क्रायो अपर स्टेज
This is the third stage.
75 किलोन्यूटन का प्रणोद उत्पन्न कर रहा है।
75 kilonewton ignition.
800 मिनट सेकंड्स तक जारी रहेगा।
So this will be continued for 850 seconds.
वर्तमान में सापेक्ष गति 3.49 किलोमीटर प्रति सेकंड तथा
So currently the relative velocity is 3.49 kilometer per second.
Cryo stage performance normal.
Altitude of 528 kilometers. Char and Trivandrum stations continue to extend tracking and telemetry support. When the cryo stage had commenced action, the instantaneous relative velocity was 3.5 kilometers per second. By the end of thrust upratement, it becomes 4.5 kilometers per second. For the next 400 seconds that follow, there is a significant addition in the relative velocity of up to 7.5 kilometers per second.
Cryo stage performance normal.
सभी विशिष्ट वैज्ञानिक यहाँ उपस्थित।
So specific scientists are present here to witness this great event. So the third stage is completely normal.
इसे भली भांति ट्रैक कर रहे हैं।
So they are tracking.
The altitude gained during thrust upratement is about 400 kilometers in cryo stage operational. When the thrust upratement ends, there is a considerable increase in relative velocity at a marginal loss of altitude.
Plus 8 minutes.
तृतीय चरण की यात्रा लगभग 850 सेकंड तक जारी रहेगी।
So the third stage would be continued up until 850 seconds.
Cryo stage performance normal.
जिसे संक्षिप्त में नाइसार कहते हैं, वैज्ञानिकों को प्राकृतिक खतरों
This is called NISAR.
घटनाओं जैसे भूकंप, ज्वालामुखी विस्फोट और भूस्खलन जैसी प्राकृतिक घटनाओं को बेहतर ढंग से समझने के लिए
natural disasters like landslide
भेदने की क्षमता के कारण यह तूफान और बाढ़ जैसी मौसमी
penetrates the clouds
व सटीक जानकारी उपलब्ध कराने में
and this will provide the real-time information about
मदद मिलेगी। यह बर्फ की चादर, ग्लेशियर और समुद्री बर्फ में परिवर्तन जैसे
So the changes in the glaciers, the thickness of ice,
साथ ही वनों की कटाई, वनाग्नि तथा
so the
से बर्फ से ढकी हुई जमीनों का
deforestation,
यह एक
the
अग्रणी
problems of deforestation can also be mitigated.
बारे में वैज्ञानिक जानकारी का खजाना प्रदान करेगा.
So this will provide the scientific information.
वैज्ञानिक आपस में जुड़ चुके हैं तथा आपसी
The scientists are combined together. So this is a very ambitious mission.
NISAR, or the NASA-ISRO Synthetic Aperture Radar, is a remarkable milestone in the Indo-US space ties. Designed on the I-3K mainframe bus, NISAR will render services for the next 5 years according to free and open data policy. NISAR provides a means of disentangling and clarifying spatially and temporally complex phenomena ranging from ecosystem disturbances to ice sheet collapse and natural hazards including earthquakes, tsunamis, volcanoes and landslides. ISRO has identified a range of applications of particular relevance to India that the mission will address,
performance normal,
including monitoring agricultural biomass over India, monitoring and assessing disasters to which India responds, studying snow and glaciers in the Himalayas, and studying Indian coastal and near-shore oceans by monitoring annual changes in bathymetry along the deltaic regions, shoreline, and migration. The changes that Earth is undergoing in its ecosystem, deformation, and cryospheric sciences emphasizes the urgent and constant need to observe Earth from the vantage of space in order to thrive on our changing planets in decades to come. NISAR offers centimeter-level precision capable of detecting subtle ground shifts and environmental changes. Data from NISAR will provide critical insights to help India and US plan for natural and human-caused hazards. Today, when the GSLV F-16 rocket of ISRO places NISAR in its intended orbit, a critical deployment event, that is, of the 12-meter wide mesh reflector will take place. This mesh reflector acts as a radar antenna. The deployment will be a slow sequence to ensure the delicate boom and antenna unfold without damage or misalignment. The deployment will begin 10 days after launch and will be carried out over the next 8 days.
Plus 12 minutes.
To prepare NISAR for science operations, in-orbit checkout, physical deployment of all deployable parts, checking out the engineering systems, testing the radars independently and jointly, this phase will last for 90 days after the launch. Extensive calibration and validation activities will take place throughout the first 5 months. The schedule of science observations alone will be driven by a variety of inputs, including L and S band target maps, radar mode tables, and spacecraft and ground station constraints and capabilities.
तृतीय चरण क्रायो अपर स्टेज
Third stage, cryo stage, ignition is completely normal. The relative velocity
तथा
4.9 kilometer per second, and altitude is 788 kilometer.
पृथ्वी की भूमि तथा बर्फ का अध्ययन करने के लिए सिंथेटिक अपर्चर रडार
Synthetic aperture radar capacity is used.
और फिर
So this will give the data.
संकेतों को प्राप्त कर 3D चित्रित
The changed signals will be sent.
12 मीटर व्यास वाले unfurlable
So there is a 12-meter wide reflector antenna is attached.
में 2 बार एक ही जगह से निकल सकता है
Two times.
और इस समय में चित्र में बदलाव से पृथ्वी में की सतह पर आए बदलावों को
Earth.
कर सकते हैं।
We
नाइसार
can
अंतरिक्षयान
study.
नासा और इसरो द्वारा तैयार
NISAR,
सबसे उन्नत रडार प्रणाली वाला उपग्रह है।
this is the
सिंथेटिक अपर्चर रडार की तुलना में अत्यधिक शक्तिशाली है।
This is a very powerful synthetic radars available here. This is the
L-band
25 centimeter wavelength L-band radar system used by NASA.
S-band radar system
So the
हर एक प्रणाली
other one is the NISAR.
जैसे कि मिट्टी में नमी, सतह का खुरदरापन और गति। निसार सूर्य तुल्यकालिक कक्षा में काम करने जा रहा है। इसके एंटीना एक खास विन्यास में
Its antenna is
अभूतपूर्व
Antarctica.
यह अंटार्कटिका
We can observe the Antarctica as well.
सटीक अध्ययन के लिए बहुत महत्वपूर्ण माना जा रहा है।
This is very important to study the melting of ice in Antarctica as well.
के मुख्य मिशन के दौरान
So 3 years main mission, the data would be provided.
डेटा के बराबर है।
So this is the 80 terabyte data.
संसाधित, संग्रहित और वितरित किया जाएगा।
This will be distributed.
सभी S-band और L-band data,
all the S-band and L-band data will be national remote sensing, and so government of India will be used. It will be provided to other countries as well.
NASA ने
NASA has 1978. They have started
ने विमान व अंतरिक्ष से विज्ञान क्षेत्रों के अध्ययन के लिए अग्रणी रहे हैं।
For the study of space.
में विस्तृत श्रृंखला 2012 में रडार इमेजिंग
2012
और 2022
in 2000
नाइसार व्यापक के साथ उच्च रिजोल्यूशन के डेटा निरंतर
so high resolution data would be available.
We are 16 minutes, 15 seconds past the launch. Now the cryogenic upper stage is currently thrusting. The vehicle trajectory correctly follows the prediction.
Cryo stage performance normal.
तृतीय व अंतिम चरण GSLV Mark II का क्रायो अपर स्टेज के नाम से जाना जाता है।
Cryo upper stage
वर्तमान में पूरी तरह
currently completely normal performance, all the
सामान्य निष्पादन करते हुए
system
यान को उद्दिष्ट कक्षा की ओर
so the vehicle is targeted to the designated orbit.
कक्षा की स्थितियां प्राप्त करते ही क्रायोजेनिक इंजन को बंद कर दिया जाएगा।
Cryogenic engine would be closed.
The launch vehicle is at an altitude of 748 kilometers.
कक्षा की स्थितियां प्राप्त होते ही उपग्रह नाइसार को
as soon as the situation in the orbit,
awaiting the satellite separation event.
Cryo stage performance normal.
Plus 18 minutes.
वर्तमान में सापेक्ष गति 7.35 किलोमीटर प्रति सेकंड तथा ऊंचाई 745 किलोमीटर होती है।
Performance normal.
so currently 7.35 kilometer per second is the relative velocity, and
It's performing nominally.
Stage thrust cutoff.
The thrust has been cut off of the cryo stage, and next event is the NISAR separation, which is perhaps very close.
जी हाँ, जैसा अपेक्षित था।
yes, as expected. This has been confirmed. The NISAR has been separated.
The NISAR satellite into its designated injection orbit. The GSLV F-16 NISAR mission is successfully accomplished.
History has been written today as NISAR has been placed in the orbit successfully. Many hearty congratulations to ISRO, NASA, and the users worldwide who will derive benefits of the Earth observation with this state-of-the-art NASA-ISRO synthetic aperture radar satellite. Do stay tuned. Tune in for the address by Secretary DOS and Chairman ISRO and mission executives. We take leave from you. Namaskar.
Yes, प्रक्षेपण के साथ नाइसार का प्रमोशन
With this launching, the launch mission has been successful.
शुभकामनाएं.
So congratulations to all viewers and the scientists. So we will be taking you to the address of the scientists.
Either none. CS announced. Project director also, project satellite project. Please. On. Very good evening to all of you. I am extremely happy to announce that GSLV F-16 vehicle has successfully and precisely injected the NASA-ISRO synthetic aperture radar satellite, NISAR satellite, weighing 2,300 kg into its intended orbit. Let me congratulate all the teams from ISRO and NASA JPL on this outstanding success. This is our 102nd launch from Sriharikota and the 18th mission of GSLV. As all of you may recall, we had the previous GSLV F-15 mission on 29th January 2025, which was the 100th successful mission launched from Sriharikota, and also the first launch after the new management, including me, took over as the chairman of ISRO. This is the first GSLV mission to the Sun synchronous polar orbit. Till date, all the GSLV missions have been to GTO. Being the first SSPO mission, several analyses and studies were carried out to make this mission a grand successful mission, including the cryogenic upper stage corrections. A host of mission simulations were carried out very systematically and meticulously, and today's successful mission is accomplished. All the vehicle system performance were quite normal, as expected and as predicted. And today, we achieved the intended orbit. Actually, we have got the orbit position of less than 3 kilometers as against the permissible level of 20 kilometers. Perigee, the specification is 742 kilometers. We have got 740 kilometers. Apogee, 745 kilometers is the specification. We have got 747 kilometers. And all the parameters are as expected and in the right line. And this accomplishment is a teamwork, culmination of the teamwork of both ISRO and JPL NASA. The NISAR satellite is a significant milestone for both Department of Space and NASA JPL, being the first joint development project undertaken by the two major spacefaring nations. NISAR is an all-weather, day-night imaging satellite that will scan the entire Earth at 12-day interval. The satellite integrates ISRO's S-band synthetic aperture radar payload with NASA's L-band SAR payload and 12-meter unfurlable reflected antenna to become the first of its kind, a dual-frequency SAR satellite. NISAR will enable the scientific community to detect the surface variations, sea ice detection, invest natural hazards, monitor soil moisture, and many other applications. The potential applications from the satellite are huge, and the global scientific community is eagerly awaiting the satellite data for their respective research and usage. The implementation arrangement between ISRO and NASA for a joint Earth observation satellite mission was signed on 30th September 2014. Between then, it was signed by the then Chairman ISRO, Secretary Department of Space, Dr. K. Radhakrishnan, who is sitting in front of us, and with the NASA Administrator, Mr. Charles Bolden. In fact, we were so happy to participate in that function which happened in Toronto. Since then, the realization of satellite in ISRO progressed steadily under the outstanding leadership of subsequent Chairman, Sri Kiran Kumar Sir, who is also present in the audience, Dr. K. Sivan, Dr. Somnath, and also under different project directors. On this occasion, let me congratulate all of them, also salute each and every one of the team members who have contributed for this significant achievement. Let me also congratulate all the technical teams, administrative teams, both in NASA, JPL, and ISRO, who worked shoulder to shoulder to build the satellite at UR Rao Satellite Center over the past so many years. NISAR mission has brought the two space agencies much closer than ever before, and the continuous interactions at various levels during the course of project execution has enriched both sides. On behalf of Department of Space and ISRO, let me thank the NASA JPL team and all other stakeholders in the project for their excellent contribution to the joint mission. Also congratulate them on the successful launch. We wish the scientific community from both sides the exciting days ahead. Let me also congratulate the ISRO teams from SAC, URSC, VSSC, IASU, IPRC, LPSC, ISTRAC, and all the teams involved in the payload development, satellite integration, realization of solid, liquid, and cryogenic stages, inertial systems, and the launch vehicle itself. Let me take the opportunity to congratulate the Chairman Launch Authorization Board, all the center directors who are with me. It's a teamwork done by ISRO along with the NASA. I express my heartfelt gratitude to the Honorable Prime Minister, Sri Narendra Modi ji, who as the Minister of Space has provided outstanding, encouraging support for the entire project for its successful execution today. Also, let me thank Honorable Minister of State, Dr. Jitendra Singh ji, officials, PMO officials who are working hand in hand with the Department of Space, and all our family members, entire team members of ISRO, and the academia and industrial participants who have contributed for this. I think at this point of time, this success is demonstrating a teamwork, an international teamwork between two spacefaring nations, and surely this data is going to be highly useful for the scientific community of the globe. And when every 12 days when the data is going to come, it is not going to be used by one or two countries. The entire globe is going to benefit out of this great accomplishment. And at this point, once again, let me congratulate all the team members, our family members, industrial partners, academia team, and the NASA team for the outstanding work. At this point, before I hand over to my team, let me invite Cassie Swiles, Deputy Assistant Administrator at NASA, for expressing her thoughts on the journey so far in this joint outstanding mission. Madam, please, floor is yours. Yeah, please.
Well, I first have to start with go ISRO, go NASA, go NISAR. So I am honored to be here today in the ISRO Mission Control Center. It's just truly been an incredible visit so far, and I have to tell you, I had an opportunity. I'm sitting next to our charge. It's just an honor to have you here, so thank you, sir, for being here. The former ISRO chairman, I looked at him right after the launch, and I said, so how does it feel to not be on console? He said, well, it's a different seat, so it's good to not be in the hot seat. So I'm glad you got to watch the launch and enjoy it. But on behalf of NASA, I want to congratulate all of the teams. It has been just an incredible decade culminating in this moment, from the technical collaborations, the cultural understandings, getting to know each other, building that team across continents, across time zones, missing nights, missing weekends with families, holidays. It is truly something that every single person in this room should be proud of. I am so proud. I was so proud to be out there watching this launch. Dragonflies flying above, just picture perfect, and I could not be more proud of these teams. You know, and this mission, it's truly a pathfinder, not just in regards to our technical, because those are truly incredible. This Earth science mission is one of a kind and really shows the world what our two nations can do. But more so than that, it really is a pathfinder for the relationship building that we see across our two nations, you know, across India, the United States, building upon decades of collaborations that already existed. And I cannot be more proud to be here representing the U.S. and really representing the teams that have been working so closely behind the scenes to make this happen. I also want to thank, I saw, several family members, both, last night on the U.S. side. I saw several family members here. So I want to thank the families. It's no small sacrifice seeing your loved ones work day in and day out on a mission that takes over a decade to build. So thank you for your support of the incredible, technical, talented people in this room. And I really, really cannot wait for continued partnerships as we go forward, building on Chandrayaan, Axiom 4, and now NISAR. So thank you. Congratulations. Go NISAR. Go India. Go the United States.
So congratulations once again. Now,
if you're just joining us, I'm Raquel Villanueva with Dr. Sue Owen, live from NASA's Jet Propulsion Laboratory in Southern California. We were just watching celebratory speeches from India after our colleagues at the Indian Space Research Organization launched NISAR about 30 minutes ago. NISAR is a joint mission between NASA and ISRO. It's a powerful Earth-observing satellite built to track changes on our planet. And launch was a spectacular sight. Right, Sue?
It was really amazing. And, we were here at the Mission Control Center here watching the launch, and it was just so exciting. We had our lucky peanuts. It's a special NASA tradition to have peanuts for launch. And so, it was really moving to see NISAR finally making its way into space.
It was great to see you get emotional watching it too, eating your lucky peanuts. And we weren't the only ones celebrating here at JPL. Here's a look at our mission control and friends and family inside Von Karman Auditorium reacting to launch.
Yeah, everybody was just so excited. You can see people clapping and cheering. It was a great event.
I know, we're right next door to the mission control, so we could really hear them cheering at each milestone. Now, our home planet is constantly changing in a variety of ways, some subtle, others dramatic. NISAR will enable us to comprehensively monitor Earth's land and ice surfaces, building a detailed record of large and small changes over time.
With NISAR, we're tracking the changes of the solid Earth and how it's moving, ecosystems, ice cover, and any other thing that's changing at the scale of a centimeter on the Earth in a way that we've never been able to see before. Because of these very subtle motions we can measure, we're able to understand what's happening below the surface of the Earth at great precision. We can see subsidence, and that allows us then to manage resources of what's happening below the Earth.
Scientists want to study the movements of the Earth's surface to understand the processes that could trigger earthquakes, volcanoes, and landslides.
And that allows us then to understand risks associated with natural hazards,
which in turn can help in mitigation measures and early response. Other changes over the Earth's surface include melting of glaciers and ice sheets, changes in forest biomass, soil moisture, and shoreline changes.
It's based on radar, so it has two different frequency radars, and it basically looks through clouds and sees the surface of the Earth. What you're seeing is an animation of how the radar collects data, and you can see these beams coming down from the antenna and coming back, and on the ground you can see the swath, and that's where it collects the data, and when it combines them all together you get what we need for the science.
We can see day and night through clouds, and we're covering all of the land and all of the ice-covered surfaces of Earth every week. NISAR is quite unique in that it has two radars, one provided by NASA, one provided by ISRO, the Indian Space Research Organization.
NASA and ISRO have collaborated in this mission. Till last year we were there at JPL, NASA, where the radars got integrated and tested and were shipped back to India. And now the spacecraft is getting integrated with the instruments and they are being tested together. NISAR is going to be launched from Sriharikota, which is a ISRO launch pad, and it is going to be launched by GSLV Mark II. So we are just looking forward for the launch of NISAR in the forthcoming year.
NISAR is measuring the changes on the Earth's surface, which are either factors or indicators of climate change. The society will also immensely benefit due to its contribution towards disaster management and providing food and water security.
These things are global problems that the global community needs to come together to resolve.
Now it looks like we are no more belonging to two different worlds, and we all belong to the space community. That's it.
There's the excitement about what we are going to learn that we didn't even anticipate we were going to learn.
This mission has been years in the making, and one of the people who helped bring it to life is with us right now. Charles Alachi is the former director of JPL, a member of the NISAR science team, and we are sitting in a room named after him. Charles, it is great to have you with us.
Well, thank you. Thank you.
How are you feeling after witnessing launch?
Well, to say ecstatic is an understatement. This is a great day. I want to start by thanking our colleagues in ISRO and India for the perfect launch. We have been working together on this for almost 15 years, and I was delighted to see many of the faces that we worked with, at the Indian Control Center, and many of the people here at JPL who have spent, more than a decade, including the team members sitting here, spent more than a decade to make this happen. This is a great day.
Fantastic.
So, Dr. Alachi, you actually pioneered the evolution of radar technology here at JPL. How does NISAR embody that tradition of innovation?
Well, it's really in the spirit of their Mighty Six, which is the spirit, of JPL. I remember when I first came here, all the radar team used to sit in one room. We were like 7, 8 people. And now you look at it, how much advances were made. NASA and JPL really were the foundational start of spaceborne synthetic aperture radar, starting with CSAT and a series of shuttle imaging radar mission. We developed and demonstrated multispectral, meaning colored radar. We developed the interferometric techniques that are being used now, and now using SAR for Earth observation is being used by industry, many nations who are participating in this endeavor. But NISAR is going to do the next quantum jump. We are going to be able to actually map the planet every week down to changes in the centimeters. That's a fraction of an inch. So we are going to be watching our planet actually breathing, as a result of natural changes or human-driven changes, floods, pumping water. So it's really going to open a whole new domain that is going to really impact in a major way how do we observe our planet.
Thank you. That's great.
Absolutely. And, you were mentioning those small changes. So NISAR will detect changes on the Earth's surface with remarkable precision. So how will NISAR's data benefit society for years to come in the near future and for the future generations?
Well, let's take one example, the floods which happened recently in Texas. NISAR will be able to actually monitor the changes of the area which are being flooded, even under vegetation. And then when earthquakes happen, we would be able to monitor the surface motion which results from earthquake, so we can send the information, to the rescuers, so they know where are, the major damage which have happened. Let's take example where people are pumping water, farmers are pumping water. We'll be able to monitor how much the water table is being depleted and how much is being refilled, during the winter when there are rain, both here and in India and worldwide. So I think it's going to impact us in a significant way, in a positive way, in helping us, better manage our resources, prevent, or not necessarily prevent, but actually how do we manage natural disaster. I mean, recently there was a big earthquake in Japan, in Russia. So there is possibility of tides and flooding around coastal region. So a satellite like NISAR will be able to monitor that on a regular basis. So it's really going to impact not only our scientific understanding, but our day-to-day life. So I would envision that people would be getting on their iPhone, map of the region or on a global basis to see what are the changes and how do we mitigate disasters which are happening.
So many communities will benefit from NISAR's data.
Absolutely, worldwide.
Well, thank you so much for sharing your insights with us today, Charles.
Well, thank you very much, and go NISAR.
Go NISAR.
Go NISAR.
Thank you. So, Sue, we are waiting for our ISRO colleagues to confirm acquisition of signal, but looking ahead, what comes next for NISAR?
So over the next 10 days, the satellite will be, they'll be checking out the satellite, and then in about 10 days, they will start deploying the antenna reflector. So the boom will, you can see here on the video here, the boom will be, the hinges will be fired so that the boom will get into place, and then once that is into place, you'll see the reflector itself start to bloom, and that will take place over days. They want to do this slowly and carefully to make sure that everything is working well, and then after that they'll be turning on the radar instruments separately and together, making sure all of the radar technology is working well, and then after 90 days we will start collecting science observations.
So there's a lot to look forward to.
Yes, there is.
Well, that wraps up our coverage for today. Thank you for joining me on the desk today, Sue.
Thank you, Raquel. It's been really great having you here as a launch buddy.
Yes, witnessing the launch together is fantastic. So this marks the beginning of a mission that will help us better understand our dynamic and changing planet. To hear the latest updates on NISAR, visit go.nasa.gov/NISAR blog. You might hear cheering in the background, perhaps a new milestone. We'll leave you alone with a replay of launch. Have a great day.
8 seconds पर L40s का प्रज्वलन हम देखेंगे.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust. S139 motor ignited.
5 seconds.
That's a magnificent of the GSLV F-16 NISAR mission. The deafening roar of GSLV and beautiful silhouette brightening the Sriharikota sky.
जी हाँ, अभी आपने देखा चारों L40s और S139 का सफल प्रज्वलन और GSLV F-16 का उत्थापन द्वितीय प्रमोचन मंच से, और ये अपने गंतव्य की ओर बढ़ता हुआ. हम यहाँ कंपन महसूस कर पा रहे हैं मिशन नियंत्रण केंद्र पर.
The first stage of GSLV with S139 solid core motor and 4 L40 liquid strap-ons thrusting together. 7,800 kN cumulative thrust.